Okay, so AI adoption shows absolutely no signs of slowing down. In fact, the pace is probably increasing more and more as time goes by, and that's just placing more and more pressure when it comes to global data center capacity. Is that pretty much where we're at the moment?
Well, I think if you look at Phil, if you look at a new report from JLL, we're going to see an estimated 10 gigawatt of new data center capacity projected to break ground across the globe in hyperscale and colo landscape this year alone. And the market is expected to expand, well, we think somewhere around 15 to 20% through to about 2027, probably slightly beyond that. And in the UK and I, of course, this digital and consumer economy, they're quickly changing, right? With AI fueling, I think into the industrial revolution as well. And I've seen an unprecedented pace and change of direction, and certainly in manufacturing, where you're seeing more and more use cases of the technology coming through. So I see it more and more. I think you were at present last year at Wellcome Sanger Institute in Cambridge. I've seen it in some of the manufacturing, notably around high performance areas like maybe Formula One as one great example of where you're seeing AI start to come to the fore and really utilizing the platforms to gain greater insights into performance. And of course, when I think about what we're doing here in the UK as well, you've seen it in the past few weeks for the announcement from governments in particular around defence and our own sovereignty as well. And I think we're seeking new ways, of course, to capitalise on the AI opportunity. So I think no, in a short word, I don't see it slowing down. And I think with the capacity that's coming, we can only see a trajectory that takes us into a real positive domain over the next few years at least.
And obviously during the pandemic, the sort of data center industry and the wider IT space got a sort of reputation for being the fourth utility, if you like, to help everyone, carry on as well. Is it right to say that status is potentially coming back now for the reasons you've sort of explained, that AI is just so front and center to almost every business activity, let alone, I guess, what we all get up to with our devices and stuff at home, that it's becoming that important alongside, the electricity and all the rest of those utilities?
Yeah, well, of course, Phil. I mean, I think, the critical national infrastructure announcement where we finally acknowledged that data centers play a pivotal role in the utilities around our country was from my perspective, a great move by the government, because what it did was it brought it to the fore. And then I think the great thing about our industry, it's been kind of kept the world's best secret for quite a long time. And then two letters have changed the PR of our industry, I think, and those two letters are AI. So everybody knows AI, of course, now. It's really driven, and you can see certainly in the press. You only need to turn on the TV for about half an hour, and you see either a clip from Jensen Huang from NVIDIA, or you hear about Microsoft, Google, and the hyperscalers generally in our world talking about AI, which has helped elevate, I think, data centers more broadly. So we're delighted, and I've been advocating for data centers to be viewed as the fourth utility for quite some time, alongside the top three. And I think, the reality is the other three utilities actually today do not operate without the fourth, which is the data that we need to help become more sustainable, more operationally efficient as well throughout our infrastructure across the UK. And when I think about what the role and the pivotal role that data centers play in critical national infrastructure, they are the fulcrum of what makes our water, our gas, and our electric run. And I say run, get pushed around the country. And that's really the foundation now. No longer is it just the copper or the steel from an electricity point of view. It is the data, and how do we control our networks to best utilize, and as I mentioned earlier, optimize those power sources or energy sources and push them around the UK.
But I guess we have to, at the same time, for all the sort of excitement and the positives, we have to acknowledge that the AI era is not without certain challenges, and I guess it's fairly well documented that the increase in energy use power requirement, I think data centers from, was it 1 or 2% potentially going to head up to 5 or even 6%, global power consumption. So that's a fairly significant increase. So, and I know the industry is obviously already working to address that, but is it really time again to draw a line in the sand and say from now on we really do need as an industry to get very, very serious about optimizing power consumption and usage within data centers, as opposed to, almost it's been tinkering at the edges, but is this a moment to really sort of focus the mind, if you like?
Yeah, I think that's a fair comment, Phil. I mean, focusing the mind is one way to look at this. And then I think about, the challenges that we see ahead of ourselves, because you're right, there is a challenge ahead of ourselves. And, in the data center industry, I think we at Schneider actually don't see this as a roadblock. We believe it's actually a call to think about the way that we innovate and the way that we do that inside of an ecosystem. So I don't think it's just a technology play. I think there's a mindset shift as well. And also, I don't think companies, even though Schneider Electric is a huge company, we haven't got all the answers. And I think playing a role within the ecosystem, either from a technology standpoint, from a legislative design and build with governments, is a role that we're very keen to play an active role in. And then I think, couple that with the embracement of alternative energy sources. I think about, the stuff that we're doing around PPAs, for example. Perhaps we'll come back onto that in a short while, but we're doing some really great work globally on this topic with a number of the largest colos and hyperscalers. So we'll come back to that. But I think, there's the dawn of, SMRs. When will that come to us properly? Who knows in the future? There's some discussion around 2030 to 2035 for that to really take a hold globally. And then I think we've got our own opportunity, even in legacy sites and legacy data centers, where we really should be thinking about how we optimize what we do today. And I think we've got a little bit to learn from other areas, other sectors. And I draw on examples from across industry where we've seen some fantastic opportunities for optimization of energy usage, up to 20-30% in some cases. But then I also draw on our own experience and what we're doing in data centers around the globe, whether that be on edge, prem, or up in the cloud, where we've seen some significant reduction in just energy usage itself, with the use of maybe technologies like digital twin or optimization software. So I think it does come with its challenges, but I think what it's going to do for us, Phil, is really help us think faster and be more agile in terms of what we could bring to market that allows us to be as optimized as we possibly can.
Okay, and in terms of, I guess, one of the main objectives, I don't know how achievable it is, but at least it helps focus, decoupling data center growth from energy consumption. I mean, that's a nice, I guess, objective. Is it, how achievable, I suppose, is it? Is the practical question.
Well, I think we draw on the point I just made, which is around efficiency and the kind of sustainability focus. So I think one part of my answer to your previous question was just talking about how do we optimize any given plant or data center in the future, and we'll maybe come back to that in a short while. But I also think there's a bigger role for us to play thinking about the whole sustainability story. So we've been targeting and working on our newest product developments to think about how do we remove carbon, so decarbonising our product set. So, getting the embedded carbon right out of our product set, whether that be from design, size, scale, transportation, where we build, how we build. We've been thinking really heavily about that and the impact that we could have in the ecosystem. So that's one piece of the story, which I think is often forgotten. Another piece of the story is how do we utilize actually AI from an optimization perspective, in particular around cooling and energy efficient infrastructure, and this can help balance both the growth alongside sustainability as well. And then when you think about, I suppose, the way that we are calling that compute today, HVAC systems have been clearly demonstrating, energy and carbon savings for quite some time, especially in real world applications. But as we move into I guess, the dawn of liquid cooling, so with our new company that we've acquired in Motive Air, we're looking forward to seeing how our technologies merge together to give the most optimized liquid cooling solutions too. And then I think, none of this is possible really without a strategy. And we need to think, just a little bit broader in terms of how we set those targets. Because I think that's important, and be transparent on your progress along the road. And also think about the adoption of sustainable compute strategies. So that means, how we, the new chipsets are actually more efficient. So how do we publicize that fact, and how do we decouple the power that's needed to power that chipset, and do a versus piece of maths alongside it's more efficient but takes more power. So where does that sit as on the equilibrium? And then, renewable energy, of course, is going to be critical over the coming years, alongside, and I go back to, industry collaboration and working inside the ecosystem will be really critical in shaping a greener, more efficient future for data centers.
Yeah, so clearly energy efficiency, sustainability have to be front and center, but I'm also thinking that in terms of innovation, is it time, I won't say to throw away the rule book, but do we need to get that mindset when even everything from sort of data center design and construction, perhaps too many people are still assuming, this is how we build a data center because that's how we've always built it, as opposed to sort of maybe starting with a blank piece of paper. And I know, some people are suggesting you can build them out of timber, etc. Everything from sort of that all the way through. Just your thoughts as to how ready the industry is and how necessary it is for people to sort of maybe challenge long held assumptions about how data centers are built, operated, etc.
Yeah, I mean, this is a great question, and it's one of my favorite ones because I'm all for us trying to think of different ways to get to the same end goal. And I think you've made some good points there around maybe some of the materials that we're using to build traditional, what I call stick build data centers. And I remember once I was working with a well-known water industry, actually going back to one of the utilities earlier, and the CEO said to his construction team, I want you to remove the embodied carbon in each of our construction sites by 25%. And I'm sure you can imagine the kind of looks in the room and the chitter chatter around, well, how the hell are we going to do this? But they did it. In fact, they removed 30% just by thinking differently with, again, their suppliers, to think, how do I decarbonize throughout the whole chain? Because again, we do have an obsession with the energy used, and we should have, but there are so many other facets to the way that we build a data center. So I think design and construction it'll have to evolve. I think how will it evolve? It will evolve through technologies that are constantly evolving and driven by AI, of course, like digital twin. The way that we design our power networks will also become even more prevalent, I think, over the coming years, because we now want to see power systems that are aligned with the loads, either whether that be AI or through GPU or CPU technologies. We want to start to think about how do we start designing for that, which is what I was alluding to earlier with our our newly launched UPS, which is 70% smaller but also 70% less embodied carbon. So it's a good start. It's part of the infrastructure, so it plays its role, but we need to, think about that more broadly. And then, so that's one aspect. So I think the adoption of energy efficient power systems throughout the chain will further enhance efficiency by all that optimization of not just power consumption but thermal management. And then I look at and I go back to kind of like the energy management and monitoring piece. So we'll start to talk about, and we used to call this predictive analytics. In today's world, we'd call that AI powered solutions. Like some of the stuff that you can see, that we have in our portfolio that enables, real time energy tracking, carbon emission reporting, and performance optimization, enabling end users, clients, users, maybe even the consumer in the future, to see how proactive certain organizations are in managing their energy and carbon usage through tools such as that. And then I think there's the kind of how we think about ensuring sustainable energy sources. And I did touch on this earlier around PPA. So that's a procurement strategy, really. And how do we purchase for more green in that space? And also things like grid interactive energy storage as well can enhance the energy resilience. And that's another topic we've not touched on yet, Phil, but is energy resilience. So how do we protect ourselves and back up, all whilst thinking about reducing our carbon footprint? And of course, we have to think of ways, and we have this technology today, but it's about how do we coordinate that ecosystem, whether it's on site, a campus, or across multiple sites, to manage the grid power sources. And I believe this is essential for long-term sustainability. So how do you draw on certain energy sources over its life cycle to make it most optimized?
Okay, and I know Schneider Electric, one of your sort of mantras or whatever is that you're working to bend the energy curve of AI, which is great, great. And I think in terms of the practicalities, that means things like employing science-based approach to energy intelligence, and as I think you've sort of alluded to a couple of times, integrating data center infrastructure with AI-driven applications. So perhaps you can just sort of fill out that picture as to bending the energy curve of AI. What does that mean in practical terms?
Yeah, no, I think bending the energy curve is something that we've been advocating for a little while. And as you alluded to there, Phil, and thanks for doing that. I think a science-based approach to bending the curve is critical. So I think what that means is, how do we utilize the data that we've built up and learned already in a number of different sites and utilities across the globe, and really reflect and use the AI then to help us understand, well, how do we best optimize? So it really is about using the AI of the future to really give us that energy intelligence for sustainability. But whilst thinking about this, how do we also have inputs into this from a people perspective and a skill set perspective, in particular, thinking about people who cross-fertilize across industries. So I mentioned about people who have been working in maybe water or electricity in the past. So how do we have that human interaction with the whole AI models? And then I think how do we use both the monitoring and the control, both as insights and tools to help us think about maybe some of the broader topics. So whilst we might be learning and thinking about bending the energy curve from an AI perspective in the data centers of the future, I think it's then upon us, once we've learned how to do that, is to think more broadly into scope 2 and scope 3, to think, well, how in our ecosystem now can we learn from what we've done here and take that and give it to the data center customers of the future and now, to help them do the same in scope 2, scope 3. So I think and again, I keep going back to it, but collaboration and ecosystem will help us solve for some of these. But I will go back to this will all be science-based and give us really the data that we need to help mitigate the bending of that curve in the wrong direction and take it down to where we need it to be.
Yeah, and in terms of sort of the solutions that yourselves are introducing to sort of help with this approach, I think you fairly recently introduced a sort of proactive asset management strategy for data centers. So I can't remember if that was introduced at DCW or was before, but anyway, that probably doesn't matter too much. But what is it? What are you hoping to achieve with it, I guess?
Well, one of the things our customers have been, and this is multi-sector across the globe, one of the things our customers have been asking for a number of years, and which we've been servicing them with, is digital services, rather than so many interventions or skilled people coming on site to make maintenance changes, which were date-driven in the past. And what we've been working on, and very successfully actually driving our digital services business, is working on that off-site view of the world that allows us to digitally connect to our customers' assets. And what that does is it's done two things actually, Phil. It's enabled us to get greater insights into our own products, to see how they perform, and maybe see if we've got issues in the field, or if we've got some products which are performing really well and what we might want to, further promote in different industries because of the capacity we think we can get from a product or solution. And the second thing, which is probably most important to our customers actually, is that we give them access to the performance of their equipment, their site, their estate, and in some instances their global footprint, so they can see directly how their facilities are performing, and if there are any actions that need to be taken or maintenance that needs to be done. But it is more event driven, rather than somebody on a timestamp going, I need to go in and change that for every 6 months. So I think that's definitely made a big difference both to us and our customers. And furthermore, what it does do then is it makes our company think broader about, well, we're doing that in the power sphere. Well, what if we were to do that, in other aspects of solutions that we provide? So maybe cooling, or I think you just mentioned there was a topic just around digital services into one of our UPS now. So again, we're just trying to think, how do we digitize the services model that wraps around a customer's site? One, to make it more effective. Two, to make it more optimized. And of course, from a cost perspective, without the interventions, we're helping our customers, hopefully save money as well by the utilization of the technology. So it really is just thinking about comprehensive solutions that allow us and our customers to really address the biggest concerns around decarbonisation, but also risk on resilience and power resilience in particular, actually, at a site or an estate level. So yeah, we've been on this journey for quite some time, but it has taken probably over 10 years for us to get to the point where we are now, and we're seeing a real acceleration in the way that we're allowed and the way that we do connect to our customer sites to give them, the data and the backdrop to the performance of their equipment.
Okay, and I'm wondering, you mentioned digital twins earlier. I'm wondering whether digital twins are sort of part of that strategy, or if they're a sort of separate entity. But just perhaps you could explain why digital twins are have such an important role to play in, I guess, today's digital data center. What is it that they bring that has been missing before, if you like?
Yeah, and I think digital twins have been around for quite some time, Phil. I mean, I think back to my old world, in particular in oil and gas, and digital twins were a real thing there. Now, what I would say is, in the past few years, we've seen a real acceleration in terms of the operator interface, I call it, into digital twins and what that means. So that's really exciting to help us get on that curve. You may or may not have seen, but in the recent keynote speech by Jensen Huang at NVIDIA at GTC, he mentioned Schneider Electric from the angle of electrical digital twin technology for us called ETAP, and the way that integrates with an NVIDIA product called Omniverse, and it ensures, not only through the design phase, it ensures through the operational phase that we still start to lean into and pivot onto predictive maintenance. I think we just spoke about that just a few moments ago, and it will reduce, actually, without question, it will reduce the total cost of ownership, because what we've seen already is a real decline in the power and design of equipment that has been previously installed into new data centers, and we've managed to think of different ways by utilizing and mapping a data architecture in a digital twin enables us to really hone in on what product solutions we need without over specifying, I would say, on what a particular design engineer might see as a power demand in any given environment. So it gives greater visibility. So that's the first thing in the design phase, and gives us an optimized design. And then, of course, once you then come into operational phase, that digital twin now becomes your footprint. So there's two things that happen there. One is you've got insight and real-time data coming out of your system, and also then for maybe an organization that is building data centers on more than once or twice, and for those that are more global, you now have a footprint. So you've built one for, let's make up numbers, 20 megawatt here, and here's your design. That design is now your design. So you can now cut, copy, paste around the world. So I think there's some advantages there from a standardization perspective, and also from a cost point of view as well now, because we're not redesigning. It's not engineer to order, engineer to order, engineer to order. We've now got the design ready to go. I also think there's an opportunity in the future to then start to think about, well, how do we truly embed that design into the front end system that could be really kind of give us some great insight as to why any changes might need to be made in the future, so that then the repercussions of that are then flowed throughout the ecosystem of the software tool itself. So yeah, there's lots to be enjoyed by the utilization of digital twin. There is a cost up front, of course, but through the experience that we've gained with our customers, that cost is soon absorbed in the design and then the operational phase later on.
And I also know that promoting, again, you referenced earlier, promoting the importance of having resilient power infrastructure for data center in our world is important. And I guess obviously, in the UK, Heathrow wasn't long ago, and although that clearly was, not, if you like, within. But I'm just wondering, therefore, how wide do you take? I remember years ago going to Schneider in the States, and there was a sort of slightly sort of blue sky thinking that instead of having one, say, 100 megawatt data center, you'd have 25 megawatt data centers, sort of spread around, and therefore there was resilience. If one of those went down, you could rebalance, as opposed to having one that might, I know that was a bit, say, sort of off the charts, but just so how, I suppose what I'm saying is, when it comes to resilient power infrastructure, how wide do you think, for example, people are relocating a lot of data center or building data centers in Scandinavia, for example, where resilience is perhaps more guaranteed than other places. So just a long way of asking you, how would you define sort of resilient power infrastructure? How
well, I think, Phil, you've alluded to a couple of points there, haven't you? There's the kind of scale, descale, but spread mentality. So I think there is that approach. There are others that believe, and I'm talking about our customers here, there are others that believe building on scale gives you a greater sense of both optimization from an operational point of view, from a cost perspective, from a land procurement perspective, and from energy. Actually, once you get the availability of the energy, then there are some of our customers who believe that's the way to go too. And I think if you think more broadly outside of the cloud environment, there are other sectors like defense, healthcare, life science, who believe there is a nice combination of compute power needs to be on site, on edge, versus in the cloud. So I think it's a really exciting time to be part of this industry, working out how do we split the demand of both AI and the power and cooling that it needs. And I think we are going to need to think and evolve over the next period, in particular when you think about, to use one example, around NVIDIA and the development of their chipset and the power demands of each of those, and increased rack and server densities. We may even see the actual white space shrink to almost, it would seem, insignificant in the future, but everything that's wrapped around it may tend to grow a little bit. Who knows how that mathematics equation might play out. But I think the one thing that we will never get away from is that is the ability to design, build and operate a robust powertrain that gives us both greater safety, efficiency, and security. Actually, mustn't forget about security, providing a resilient foundation for AI powered innovation in the future. And I think the newer entrants into our industry, in particular those that are either neo cloud or GPU as a service, are actually thinking more small but scale from the ones that we've spoken to so far. So there are, again, it's a real mixed bag, but it's providing companies like Schneider Electric a fantastic challenge to think about how do we solve for those in the future.
Yeah, I mean, we've covered obviously quite a lot of ground there, and some brilliant thoughts and insights from yourself. I mean, is there anything else? Is there something crucial we've missed, or any other thoughts you've got, or have we you know, just about covered everything? I'm sure we haven't, but
Well, I'm sure there's more to cover, but I mean, always, clearly from a Schneider standpoint, we feel we've got an exciting year and a number of years to come ahead, working closely with our clients around the globe. We enjoy the interactions that we have. The ecosystem actually, when you look at it, is getting bigger and bigger every year, with new entrants and new ways of thinking about how we compute. So yeah, watch this space. I'm sure there will be product developments in the future. I mentioned one earlier around the decarbonisation piece. Watch this space for what comes in the future as well. I think I'm looking forward to seeing how we develop our own solutions to match everything that we've spoken about on this session, Phil.
yeah, just to that, I mean, on the roadmap, is there anything specific we should be looking out for, or initiatives or things, or is it sort of all under wraps for now, if you like?
Yeah, probably all under wraps for now, but I guarantee you we'll have more developments in the future we can actually talk to you about.
No, that's fine. I think if everyone looks at the history of Schneider, it'd be reasonable to assume that you'll be announcing quite a lot and fairly soon. But yeah, no, I won't push it. But Mark, I really appreciate the time you've given me, and I'd say some fantastic insights into what's going on in the world of AI and data centers, and just great to have some time with you. So really appreciate it. Thank you.
Thanks, Phil. Appreciate the time. Thank you.